5. Differentiation. Whole concept of differentiation we know. There are some rules and some standard derivatives we know. Using some standard derivative and partial roots of the given example, we can find out a solution of the given example. And the following function we have to given like this: y is equal to f of x. Then we obtain its definition using a continuity function limit. We know in the past standard. What the concept we know? What is a limit? What is continuity? And what is function? Using a function continuity and a limit, the unit is a differentiation. In semester 5, we are familiar what the concept of the differentiation. Based upon a differentiation, there is another unit in the semester 6, unit number 3, partial differentiation or a partial derivative. In this function, suppose we have given y is equal to 3x square plus 4x minus or plus 5. 3x square plus 4x plus 5 is a function. Here we have given a y. Then there is a x is an independent variable, y is a dependent variable. There are two variables. One is x and the other is y. We have to change x putting a 0. Then y is a 5. X is putting a 0. Then y obtain a 5. Like this. X we can put a 1. Then y is equal to 12. Then you can say that there is an unit changes in x variable. The rate of change is of y. Then we say that is the dy by dx or a differentiation of y in the respect to x. Unit changes in x. The changes of y. These are rate changes of unit changes of x. Whole rate changes in a y. We can say that is the dy by dx or a differentiation of y in the respect to x using the formula or a method. We have to derive partial derivative. Here two variables x and y. X is independent, y is dependent. But in the partial derivative, there are other variable. You can say z. Z is the partial one. More than two variable. Suppose x square plus 4x plus 3y square plus 3xy plus 10 like this. Here, two variables are there. X and y are an independent variable. Suppose we can put here 3 L M N, then L M N also variable. Then more than two variable. X is one variable, y is another, L is another, M also another. Then we can say that there are more than two variable of changes. X variable, which is a change of z, y variable, what is the change of z, L variable, which is a change of z. Then whole changes of x, y, L, M, N, then z may be a change. You can put like this: value of x, value of m, or a value of n. Then whole changes of z we can obtain. But in a general, you can say that sometimes there are changes of other variable. X may be changed, y also changes, y also changes, then we can say that z may be a changes. But we can find out how many changes the value of z. Then y may be a unchanged or a constant. X variable is a changes, y is a unchanged or a constant. Then we find out a partial derivative. There are two variables independent, x and y. Z is a dependent. From the using x is a variate, x may be a changes, y unchanged. Then we find out a partial derivative, or we can say that this is a partial derivative. Partial derivative define the notation delta. Z is a variable, delta z by delta x. From two variable, x is a changes, y unchanged, then we can say y is a constant. Then this is a notation, or it denoted by delta z by delta x is a first partial. Differentiation or a derivative. We can other notation is, if we are given z in a function of f of xy, f of xy is a 3x square plus 4xy plus 3y square, then we can symbolic delta f by delta x. Here only x may be a changes, y is a constant. Other dimension is a delta, then we can say only fx. There are three notations. Delta z by delta x, we have given a z, then we find out delta z by delta x, we have given a function f of xy, then delta f by delta x or a fx. This is the first partial derivative in the respect to x. X may be a changes, y is unchanged or a constant, then we can say this is a delta z by delta x. Same, we find out in the respect to y. Then suppose this is z, then delta z by delta y. If we put in z in the function of f x y, then delta f by delta y or a f of x y. This is the first partial derivative. Derivative in the respect to y. Then x is unchanged, x is a constant. This is the first partial derivative. Then we know in the semester 5, suppose y is given, y is equal to f of x is given in semester 5, then we find out using a function f of x, then f dash x, then we can put under dy by dx. F of x is given, then f dash x, we obtain there is a function is limit h tends to 0, fx plus h minus fx divided by h. This is a simple derivative. This is a simple derivative in a semester 5. Using this formula definition, we can obtain delta f or a delta z by delta x or a delta z by delta x. Delta z by delta x or delta f by delta x, we are given a function. Then using a definition of this simple derivative, then we can find out the formula limit h tends to 0, f x plus h y minus f of x y divided by h. This is a function or a formula of this partial derivative in the respect to x. Here x is a small increment in the x. Same. Delta f by delta y. There is a limit k tends to 0 at x y plus k minus f of xy divided by k. This is a definition. Using a definition, we can find out a partial derivative in the respect to y. Limit k tends to 0 at x. We have to increment y to x, then y plus k minus f of xy divided by k. Here k is a small increment in the variable y. This is a first partial derivative using a definition respect to x. This is second first partial derivative respect to y. Same. We can obtain a second partial derivative. Second partial derivative, we can obtain delta square z by delta x square. Delta square z by delta x square. Then we put delta by delta x, delta z by delta x. If we have given it delta square f by delta x square, then delta by delta x, delta f by delta x. This is second partial derivative in the respect to x. The same. We have to put in f x x. This is second partial derivative. Same. In the respect to x, this is second partial derivative. In the respect to y, second partial derivative is equal to if we have given it z, sorry f, then this second partial derivative denoted in or represented in fyy. Delta square f delta y square is fyy. This is second partial derivative. We have given a function f of f into bracket xy. There is a xy is a independent variable, z is a dependent variable. From using a y, first partial derivative, and we obtain a second partial derivative. Same in a combined partial derivative, we have also to obtain combined partial derivative delta square z delta y delta x. We can obtain using a formula delta of delta y delta z by delta x. This is second partial combined derivative. Second partial combined derivative we can put in a formula f of yx. Same is equal to this second partial combined derivative in the respect to y and x. This is f xy. Using a formula, we can find out any function we have given, any z function we have given, or a f of xy is given, any z function we have given, or a f of xy we have given. We find out 6 values are there. We find out 6 values. First, if we have given a function z, then there is a delta z by delta x, delta z by delta y, delta square z by delta x square, delta square z by delta y square, delta square z by delta y delta x, and delta square z by delta x delta y. We repeat any function we have given in the x or a f of x or a f of xy or z. Then we obtain 6 values. Every values delta z by delta x having 1 marks, delta z by delta y having 1 marks, or a 1/2 marks, delta z by delta x 1/2 marks, delta z by delta y 1/2 marks, maximum is 6, minimum is 3. Using the formula, we are given suppose z. We take one example. X cube plus 3x square y plus xy square minus 10. We have to find out first two values, first two derivative. Suppose delta z by delta x. Then using a semester 5 rules of this simple derivative, then 3x square, here x is to n, then nx is to n minus 1 plus 3 into 2 into y. 3y is a coefficient of x square. 3y is a coefficient of x square, then 3 into 2 x into y plus here in the respect to y, then x in the respect to x is a 1, y square, 10 is 0, therefore our answer is 3x square plus 6xy plus y square. This is the first partial derivative in the respect to x. First partial derivative in the respect to y. And here x cube we can assume constant, then 0. Coefficient of y is a 3x square. 3x square, y in the respect to y is a 1 plus x is the coefficient of y square. Y square is a 2y, 10 is a coefficient, therefore 3x square plus 2xy is our answer of delta z by delta y. Same, we can say that we have given a function f for a z. We obtain 6 values. This first value delta z by delta x 1 marks or a 1/2 marks. Delta z by delta y 1 marks or a 1/2 marks. Depends upon the concept of partial derivative. We have to see homogeneous function. To partial derivative example and concept of here, there is another is a homogeneous function. In homogeneous function, there is a f we have given or a z we have given. The function z is a homogeneous or a not, or we have given f of xy. Then using a function, this function f of xy is a homogeneous or not. Then we have to represent it in a function y is x is to n f y upon x. We can say it another way, x is to n g y upon x. Then this function f of xy, we have to represent it in the way of x is to n g y upon x, or y is to n z x upon y. Then the function given is a homogeneous function. If given function is homogeneous, then we have to other concept is a Euler theorem. Euler theorem we have to satisfy. Given function is a homogeneous, there are two ways. First is a represented in a f of xy, x is to n g y upon x, or y is to n g x upon y. Then given function is a homogeneous function. This is the first method. Second method, to find out homogeneous function, we have to put in lambda x for x. We have to put in lambda x for x and lambda y for y. After putting a lambda x for x and lambda y for y, the function represented in a lambda raised to n f of xy, then the given function f of xy is a homogeneous function of degree n. We are given a function f of xy. This function we have to using a lambda x for x and lambda y for y, we have to represent it in a lambda raised to n f of xy. Then the given function f of xy is a homogeneous function of degree n. Suppose one example we have to take. F of xy is given x square plus 3xy plus y square, xy plus 3xy, sorry, x square plus 3xy plus y square. This function is a homogeneous or a not. For the check with f, we have put for x lambda x and for y lambda y. Therefore, f lambda x or lambda y is equal to lambda x square plus 3 lambda x lambda y plus lambda y square. Here x, we put lambda x, lambda x, y lambda y, y square, lambda y square, then lambda square x square plus 3 lambda x lambda y plus lambda square y square, then lambda square x square plus 3 lambda square xy plus lambda square y square. After putting lambda, then coefficient is a lambda in the three term are there. First term is a lambda square x square, second term is a 3 lambda square xy, and third term is a lambda square y square. There is a common factor is a lambda square. Remaining is x square plus 3xy plus y square. Then here lambda degree 2, remaining is a coefficient x square plus 3xy plus y square is a function of fxy. Then you can say, then the given function f of xy is a homogeneous function of degree n. Here x square, lambda square, there is a n is a 2. Then you can say that the function is homogeneous of degree 2. If we have to complete a homogeneous function, then another is the Euler theorem. Then the condition is, for Euler theorem, pronunciation is Euler or Euler. Euler theorem is, then the condition, function f of xy, function f of xy is a homogeneous function. If f of xy is a homogeneous function, and delta f by delta x, delta f by delta y is a first partial derivative. Then there is a condition or requirement. F of xy is a homogeneous function. Delta f by delta x, delta f delta y is the first partial derivative is a respect to x and y. Then Euler theorem is x into delta f by delta x plus y into theorem. This is the Euler theorem. There is a statement only having 2 marks. X delta f by delta x plus y delta f by delta y is equal to n f of x y. n is a degree of the given function. Any function we have to report heading n f of x y. Left side is n into f of delta f delta x plus y into delta f delta y. This is the left side. N and original function f of x y is the right side. Both are equal. Then the given function is a homogeneous, and for the homogeneous function we have to prove Euler theorem. Suppose any small example you can take for the Euler theorem. Suppose any example is f of xy is given. F of xy is given x cube plus 3x square y plus y cube. X cube plus 3x square y plus y cube. For the function, we have to prove Euler theorem. For the function f of xy, x cube plus 3x square y plus y cube, if the function is homogeneous, then Euler theorem may be proven. Given function is not homogeneous, then for the function we cannot prove a Euler theorem. Suppose we find out delta f by delta x, then for Euler theorem we find out delta f by delta x, then 3x square plus 6xy plus 0. This is a delta f by delta x, 3x square plus 6xy. Delta f by delta y is a 3x square plus 3y square. Delta f by delta y is a 3x square plus 3y square. Euler theorem is x into delta f by delta x plus y into delta f by delta y is equal to n f of xy. This n is a power or a degree. Then degree you have to find out. Here n is a degree. Then x into delta f by delta x, y into delta f by delta y. You can put here x. Left side is x. Delta f by delta x plus y into delta f by delta y. X 3x square plus 6xy. 3x square plus 6xy plus y into 3x square plus 3y square. 3x square plus 3y square. X delta f by delta x, y delta f by delta y. Then total is a 3x cube plus 6x square y plus 3x square y plus 3y cube. 3x cube plus 6x square y plus 3x square y plus 3y cube. There is a every vector there is a 3 remains common, or we can one step more, 3x square plus. Therefore we find out a using a formula. In every step there are 3 is a common, then we take 3 common, the remaining part is a x cube plus 3x square y plus 3y square Then there is a 3. It's a degree, you can find out. And we also represented in n f of xy. Then we say that this is a partial derivative using a Euler theorem. Another reason. Another is a utility. In our syllabus, there is a utility function. Utility, there are many concepts we know in economics. Up to standard 11th to semester 5th, there is some concept we know: demand, supply, illustration, or a marginal cost, total cost, elasticity. Same. This is the other concept is a utility. Utility and usefulness both are different. Utility and useful both are different. Utility is one of the matter thing in every commodity or item satisfied a total utility, then we can say that this is satisfied a person in this utility. We can find out a total utility, marginal utility. Total utility means requirement of a person. Total, then you can say that this is a total utility. Marginal means one other unit. The change satisfy a person, then the extra number is a marginal utility. We are given a function, then f of xy is a function. This is a utility function. We can define u or a small u. For utility function, u or a small u is a function, you can say utility function of the person having some arrangement. Then you can say that there is a budget in our syllabus. Person A, you can say that person X require two items, A and B. Person X require two items, A and B. For A, per unit price is Px. B, per unit price By. Person A purchase is X and Y unit. Then using a xpx plus ypy is a budget function. You can divide I. U is a given utility function. Income function also we have given xpx plus ypy is equal to I. From the utility function, income function, we find out I minus xpx minus ypy is equal to 0. Then this is the first number, this is the second number, and this is the third. Then we find out a Lagrange multiplier lambda and partial derivative in the respect to x is equal to 0, in the respect to y also 0. In semester 5, we know the maximum function or a minimizer function. Then there is a two conditions are there. If first is a dy by dx is a 0, this is semester 5. If function is a maximization, then first condition is a dy by dx is 0 and second condition d square over by dx square is a less than 0. then the function may be maximized. And second is function may be minimized, then dy by dx is a 0, d square y by dx square is a greater than 0, then function may be minimized.